Today we're going to be taking a look at Homepage, which is my preferred home lab dashboard to manage all of my services running on my home network. In previous videos, I talked about apps that I'm running in my home lab and tools to manage those apps. So we've talked about remotely before on how being able to remote manage and commands, things like that. We've talked about Ansible for managing. We've talked about HomeR, which used to be my go-to dashboard for kind of managing all the servers that I'm running, all the systems I'm running, everything. Well, at the time, I took a glance at Homepage, but I decided not to go with it because I wanted something that I could configure through the UI that was more kind of 100% web-based. But I decided to take a second look at Homepage over the past few months and realized that Homepage is probably the one and only dashboard that you will ever need. And today I want to talk through how I have mine configured. I'm going to show you how to do a little bit of configuration with it, simple setup, get you up and running. Now, the one thing to know with Homepage is you don't manage it through a web UI. You actually manage it through a configuration file on the system it's running on. So you can run it in Docker, and with that, you basically, and you'll see when we go to set this up, it'll create kind of like a YAML style configuration file, and you define all your systems in that, all your endpoints, the services you want to connect to. But by doing that, you're actually able to leverage tons of functionality, and it makes it more capable than it would be trying to implement all of that in a web interface. And so while it might be a little bit more configuration up front, it allows you to do pretty much anything that you want to do, especially if you pair it up with something like N8N. So I've got an N8N instance here that I'm running on my home network, and you'll see this is actually grabbing data for Homepage, and we're going to talk about this here in a couple minutes. But before I jump into that, hop on over to Homepage, and this is kind of my dashboard of a lot of my distributed compute rentals and things that I'm running within my network. So this is how I have things set up. You can see we've got a network section where I've got my bandwidth. I've got all the devices on my network. I've got my HD home run. I even have it pulling in some crypto prices. We're going to talk about that here in a little bit on how you can leverage. Basically, you can leverage any API you want through this, which is really cool. And then I've got my Synology NAS in here. And if you notice, I can even see what the processor is, the real-time stats, my disk usage, the current top running processes, and also the current top running Docker containers on those. I can even pull in some stats from storage. So I'm running a storage provider on a VM that's running on the Synology NAS. And I'm able to pull all of this in. We're able to leverage that kind of custom API. I'm going to talk about the out-of-box connectors they have and how you can leverage some of the generic ones to use any API you want. Similar to what I talked about how I had HomeR set up before, we've got all the standard apps as well. So I've got SAB, I've got Sonar Radar, I've got ROM in here, which actually tells me how many games I have on my network, on my ROM server. We've got Plex. Moving on over, you can see that I have each of my systems here. So we've got HP Tower 1, and if I just scroll down some, you'll see 2, my compact towers. Basically, I have all of my systems here that I'm running on my network. It's quite a bit here, right? These are all systems that I have right now. If you're unfamiliar, I recently did a purchase of 2 pallets worth of older workstation PCs. And so I have a lot of these on distributed compute. Some of these have GPUs in them. Some are just CPUs. But I use this dashboard to monitor all that. And if we take a look at HP Tower 1, you can see I've got terminal here. This is actually using Shell in a Box. So I can directly from there, I can actually log into the system if I wanted to and do an SSH session without having to fire up PuTTY or anything like that. I've got my storage provider that's running on that. Again, I can click on this and actually open up that storage provider. You can see I just created this a couple days ago, so we don't have a whole lot of utilization yet. but I can hop right on over there, and you'll see the quick status here and the status here. That also reflects over here. So we've got our quick status here, and the last time their servers were able to pick the total storage we're providing and the total they are consuming. And then moving down, I'm also running AIOZ on all of my systems. So anytime I set up a system, I set up AIOZ on it, let it run in the background, and earn some crypto from that. That is a little bit of an AI platform that can tap into your unused idle resources. And then moving down, you're going to see we actually have the system section here. And you can see the processor that's in it, the CPU usage, the mem usage, the swap file usage, the kernel it's running, the operating system it's running, the system name. If we click on this, this is actually going to open up Glances. Now, Glances is something that I run on all my systems. Works great. I'm actually going to show you how to install it today, but it gives you a quick web-based dashboard of all the processes that are running, kind of your real-time network activity that you've got, your disk I/O, your disk storage. It also shows you all of your sensors, so you can check your temperatures at a glance here. And if you have a GPU, I'll show you your GPU here. This specific system has a RTX 4060 low profile in it. So this is a small form factor with a 4060. And you can see we've got a i7 6700 in here. So it's all working great. This gives you a quick glance into the system. But that information also pulls in over here through that API. Similar with the 4060, this is using, so my GPU is a 4060. I've got this little control here, and it's showing me basically the usage that I'm getting from that 4060. So this has been processing some rendering jobs for a little bit now. So you can see we had a spike up when it was rendering, and then went back idle. And then I got another render job and went up to 90% utilization, and then it dropped back off. And so this allows us to have a look into how much are GPUs actually being used over a stretch of, the past few hours. So this is nice to see. This is one of the things I really like about this. And then we've got our disk usage. And once again, we've got our top processes running, and then our top containers running. You can see right now there are no jobs running on this one. But if we scroll down a little bit here, you can actually see on Compact Tower 2, we've got a VPN job running for Okta on that one right now. And this one, Compact Tower 3, somebody's actually running this on Okta to run a Windows, kind of a Docker, really like a Windows VM in a Docker image, which I actually covered how to do it on the channel before. But they're actually running my system in order to run a Docker's VM. Not 100% sure what they're doing in this. However, they have been running this for quite a while now. And so this is a system that actually has no GPU in it. It only has a CPU. But we are earning because they're essentially running that VM. So that is what you're seeing here. It's using about 240. So it's using two of the, let's see how many cores on. This is a 3770, so this has 8 vCPUs in it. So they're using about 2.5 of the 8 actively right now. Scrolling down, we can see we've got another rental on this Dell Tower 2. And they're actually running the Nexus container. So you can see that Nexus process is running. It's an Okta MR. So that is actively running on that one. These are two systems I haven't rebuilt yet. I do want to rebuild these. But right now, this one, again, is rented. And somebody's running a Windows VM container off of this one as well. You can kind of see we're pegged that CPU. So this is a 4-core, 4-thread. And they're using every bit of that. And then moving down, we've got a couple other GPU rigs that I've got here. So this is a 3060 Ti in a tower. So you can see it was rented, then it was off, then it was rented again, off. Same thing with the 3080. It was rented for quite a bit. That rental ended about an hour or two ago. The 5070 has not been actively rented for the past couple hours, it looks like it's got a little bit of a job here and there. Lately, it's only using about 4% memory, but none on the GPU. So that might be starting to ramp up. And then I've got a couple X300s with GPUs in them, and you can see a similar thing here with those rendering jobs, those GPU rendering jobs. So it gets the job, spikes up, and then goes idle for a bit, and then repeats. And moving down, Dell Mini 1 all the way through 7. These are all CPU only systems. And so these typically only get tapped in if there's any type of CPU rendering jobs. Right now, these are all sitting idle. But this gives me a good glance at that. And on pretty much all these, the rest of these systems, I just spun up AIOZ on these last night. So these are all going to be relatively zero on the pending reward so far. And then moving on to some small form factor systems. We've got a bunch of these are sitting idle right now. I haven't set up storage on these, but I am going to be setting up storage. And so this just kind of at a quick glance, this gets you a look into what type of data you can see. You can make any of these links can be clickable. So like terminal, we're launching show in a box. And then like the AIOZ one, there's no default API, but the way I'm doing that is I'm tapping into N8N. So AIOZ has a executable that you can install on your system. And what you do is you basically install that package, and then we're able, through N8N, you can actually issue SSH commands to a remote system. So we are setting up a webhook. This is all local on my network. So we've got a webhook URL. Data gets posted to that. And then we extract out the host name. So we accept the perimeter in of the host. And then we query. So we basically run this query. And this calls the executable that is on our system. And it gets the pending balance. And then essentially returns that balance back as a formatted number. And then that will render here. And if we scroll up to the top here, you'll see like this 0.427. And I've got this set up so once I hit a balance of 1, which is the minimum to issue a payout, it gets transferred to a different wallet where I can then spend those funds. So right now you'll see we've got like 0.427 on that one, 0.39, 0.25. The power of N8N is I only need to set up one job for those. I can pass in the IP address of that system, and it will return back the data for that system. So kind of at a high level, that is how I have things set up. Now, I'm not using a lot of the controls. However, if you hop on over to Homepage's site and you go to widgets, these are all the various controls that they support out of the box. And if you find that you're trying to access an API that isn't in there, they have what's called custom API. So you come in here, as long as whatever you're calling is spitting out a JSON format, you can ingest it. And you can even set up field mappings, all of that. And it even has, so it has time reference fields. One of the things you'll notice here, I've got 8 seconds ago. This is because I'm telling it to do relative time and not a date timestamp. And you'll also notice here that it has terabytes and gigabytes. It's inferencing this because I'm telling it the data type coming back is bytes. And so it's auto converting it. So once I hit 1 terabyte of used data, this will auto switch from GB to 1 TB. And you can kind of see that over here. So I don't have to do any type of those calculations on the API side. It can handle it through the control itself. And we scroll down, they'll kind of tell you here's the relative date, and they support bitrate, they support size, they support bytes and duration, and obviously your typical text, number, floats, doubles, percents, all of that. And so they make it really easy, and you can even apply data transformations if you need to basically translate one value to another based on your response on how you want to display it on the screen. So this along with everything else that they support from a control standpoint, basically makes homepage limitless, especially if you tap into a kind of a integration platform similar to N8N, which is what I'm doing. So just kind of give you guys a couple ideas here on some of the controls that I'm using. So they have glances, which again, I'll show you how to install this, but this is actually tapping into the system resources on that system. And then they have just like general URLs that you can tap into, and that's what I'm doing to get to like show in a box, things like that. But then they also have other things. If you run Uptime Kuma or Uptime Robot, you can tap into those as well and show that information. And like Plex was on there, right? ROMM's on there. So with ROMM, you can, these are the fields that you can tap into. If you notice, I was only tapping into a couple fields there because I don't care about how many save states or screenshots I have. So lots of flexibility in this. And essentially it spins up a static page, but then each of these controls within it are kind of dynamic. They're defined in that configuration file. So now that I've given you guys an overview of kind of how I'm using it and kind of some of the functionality it has, I'm going to hop on over and I'm going to show you how to install it on a system and get it up and running. Over at the SSH window for our demo server, first thing we want to do is we want to do a, we want to make sure Docker's installed. I'm going to do docker ps-a. I already have it installed. If you don't, you can do apt install docker.io. That'll go ahead and get it installed for you. And then we're going to create a data folder. So I'm just going to put this /data. And I'm going to create a folder called homepage. This is going to store our configuration. Go ahead and hit enter there. And now we just need to really run the app. So we're going to do a docker run -d because we're going to run it detached. We're going to do a -- restart always. -p, we need to give it a port mapping. I'm just going to do port 3000 to 3000. And then we need to give an environment variable for allowed host. So it's -e space homepage _allowed _hosts equals. And I'm going to give this an asterisk, basically saying it can run on any IP there. And then we're going to do a -v. And I'm going to map /data /homepage to /app/config. And then we're going to give a volume mapping to docker.sock. And the reason we're doing this is so that it can see all the containers that are running on this system. And it's more for the container management part of it, so that we can get a glimpse into that data. And then we want ghcr.io /get homepage /homepage. We're going to do latest there. And we're going to go ahead and hit enter. And this is going to download the Docker image and run it. And it's going to have some demo data in it. Now, if we do ls on /data /homepage, you can see we now actually have some files here. And so we should be able to go over to the IP address. And there we go. So we've got 3000, and this is kind of your sample. So this is giving you some stats up here for the system it's running on. And we've just got some test groups in here. Now, what we're going to do is we're going to create a services file. So we're going to hop back on over to our SSH window. And you can see now that we've navigated there, it created the services.yaml file. So we're going to do a nano on that. And this is going to contain the configuration file for services. Now, services are kind of those controls that I showed you that I have on mine for each system. So to create one for like the demo system, we would just come in here. You can name it whatever you want. Do a : and there's going to be like 4 indents for each line. But I actually already have an example. So what I'm going to do is I'm going to clear this out. And I'm going to paste in an example for you guys. And we'll walk through it. And this is kind of like my baseline config that I do. So we're going to have the name of our system. We're going to have terminal. This is going to point to shell in a box, which we still need to install, but we'll take care of that here in a minute. System, this is going to point to Glances, which we're going to install. Again, we'll take care of that. And so system, disk, processes, you notice these all use Glances. So they all use the same API. The only difference is the metric that it pulls back. This pulls containers, this pulls process, this pulls the file system, and the system one pulls info. Now, you can also, on each of these, you can have an href, which basically gets you a clickable link of where you want to navigate to. And then site monitor, this gets you a kind of a monitor of whether that service is up or not. So it'll give you a little green dot and it'll tell you what the ping time is. And so if your service is ever down, you'll see a little red dot next to it without you having to click into it. So you'll notice that for terminal and also for system, I have those set up. And then within these, you have your widget set up. And this can all this info can be gathered on the doc site. So I'm not going to go over kind of how everything gets configured here. But we're going to do a Control X, Y, enter to save. And if we hop on over here, you notice it's auto refreshing and it auto switched over. Now, you'll notice we have an API error here, and that's because we haven't actually installed Glances and we haven't installed shell in a box. So see how it says this little 500? That means that the service is not up. So it gives us this little red dot. And obviously if we click that, there won't be a page to load. We can remedy that super easy by installing shell in a box. So we're going to do apt install, and I'm going to install pipx because we're going to need that for Glances. And I'm also going to install shell in a box. We're going to go ahead and hit Y, hit enter, let that download. Now, if we hop back on over to the dashboard, you can see that it automatically realized that it came up and it turned green. We can say our response time is 12 milliseconds to that. And if we click on it, hit proceed, we now have that SSH window. So we can right click, do white on black, and we now have the ability to SSH into that system if we want to through the web browser. Now to set up Glances, this is actually pretty simple. But we are going to set it up as a service. So we're going to do pipx install Glances. And then we're going to do square brackets. And in single quotes, I'm going to type all. We're going to do that and hit enter. Now, this is going to take a minute or two to download and install it, depending on the other stuff that's running on your system. And this isn't going to set it up as a service. We have to do some additional configuration to set it up as a service. But we're going to wait for this to finish downloading the packages. The packages are done. We can do a nano /etc/systemd/system. That's where our service files are stored. We're going to call this glances.service. And I'm going to paste in a config. And essentially, we're just creating a service called Glances. And the execute start path is /root /local/bin/Glances -w. And this is going to spin up the web server and the API server that allows homepage to connect to it. Do Control X, Y, enter to save. And now we just need to do a systemctl daemon reload. And then we can do a systemctl start Glances. It's going to start it up. And then we can do systemctl enable Glances. This will enable it to run on reboot. And now, if we hop back on over to our dashboard, you can see it now has pulled in that info. So our system's running an i5 4570. Our CPU is pretty much idle. We're using about 10% of the memory. And we have one container running, and that is our homepage container. We didn't give it a name, which is why it defaults to a randomly generated name. but that is the only Docker container that is running on this system. But this is a super easy way to get visibility into that system. And obviously you can do other things. If I hop on over, here, you can kind of see an example. This is some of the stuff that I'm running. So with storage, this is kind of what that config would look like. So you do a custom API on the widget. You give it the endpoint to the SNO API for storage. And the field mappings are this. So quick status, last pinged, disk space dot available, and disk space dot used. You give those configs and you're good to go with that. This does not have to route through N8N or anything. And then you can also give everything custom icons. So you can see I'm actually grabbing the storage logo off of the storage GitHub and using that for the icon. And then for AIOZ, we do need to create kind of a custom webhook or custom job in N8N. And that's what we're doing here. So we're calling that webhook URL. We're passing in the host. And that host is the IP address of the system that we want to check the balance on. And then we have that set up to return AIOZ underscore balance. It's returning it, and we're basically mapping it to AIOZ. And that is pretty much how everything's working. So that's all there really is to getting this up and running. And then if you want to run multiples, super easy. If we go back into our homepage config file here, you can basically just take, I do have that zoomed in a little bit, so I'm going to do cat/data/homepage services.yaml. And if we were to copy this, and let's say we had another system, I just come to the bottom here, add a line break, paste that in, and we would have like demo 2, and then whatever that system name was. Go ahead and save that. As soon as you save it and come back over here, this is going to refresh, and it's going to have that info for you. It's going to create those columns. Now, you can see this info in the docs, but there are specific style sheets. So there's settings that you can tap into, and there's also custom CSS. So if you want to style anything differently, or if you want to go in the settings and you want to control like specific APIs that are being used as the providers, you can do that from there. There's also a proxmox config. I don't use that. There's a specific Docker YAML config. I don't use that either because that's really the Docker that's running on the system, where with Glances, we're able to pull in the Docker images running on all the remote hosts, which is what I'm more interested in. But that's all there is to getting it up and running. I highly recommend considering using it, especially if there's some custom things that you're looking to do. The custom API is definitely worth it. It's worth the effort to do the configuration file. For the longest time, I kind of avoided this because I was in the mindset I didn't want to have to manage a config file. I didn't want to have to remote into the system to set everything up. And then I realized the power that it had through some of those custom widgets that you can tap into. And like I said, especially if you pair it up with like N8N with their webhook functionality, you can basically do anything you want. You can run all your mappings and everything through N8N. As I showed you guys, like basically all I'm doing is I'm calling SSH. I'm returning back the amount of pending balance, and then I'm formatting that into a JSON response, spinning that back out to homepage, and then homepage is just rendering that on the screen. So with everything running on my local network, it makes it super nice. Nothing's going out over the internet. I mean, obviously we've got some things that are doing that, like the internet bandwidth tests, but that is typical. And this is part of one of the native plugins as well. So this is Speed Test Tracker. and they have a plugin for that as well. Like I said, they have pretty much apps for almost everything that you would need. So like speed test trackers in here. And they actually give you multiple options that you can run. And that's what's allowing me to basically I run that as a Docker container. And obviously I'm not logged in right now, but that runs periodic bandwidth tests for me so that I can keep track of my bandwidth and also my ping to the speed test server. But that's it for this video. If there's any specific configuration or if there's something that you would like to see configured within homepage that you just can't figure out, leave me a comment below. I can consider doing a future video on it. If it's, a service I can run on my network or something we can tap into, I can definitely consider doing that.